On the beach and in the water, there is a part of marine life that is often misunderstood: seaweed. I've grown up visiting Northern California beaches, watching waves wash long ribbons of kelp onto the shore, but I've never known what role it played in the marine world. So for my project, I set out to learn what seaweed is, where it thrives, and why it matters. In the scientific field, seaweed is not considered a plant. It's considered an algae, and there are green, red, and brown versions of this algae. They photosynthesize, remove carbon from the water, and create kelp forests that act like underwater cities for fish, crabs, sea lions, and so many other species. I also learned that seaweeds face constant threats, such as the warming waters of Northern California and exploding sea urchin populations. I visited 3 different beaches to determine which environment suits seaweed best. In order to record my finding, I used biological illustration, which plays an essential role in science because it captures the precise structures and anatomy of organisms. In seaweed, illustrations highlight features like holdfasts, stripes, blades, and air bladders, showing their proportions and relationships. The process requires observing the specimen closely, measuring key parts, and sketching multiple views. These illustrations help researchers identify species, compare anatomy, and understand how each organism fits into its environment. In order for seaweed to thrive, it needs to have the right environment. Most seaweed needs cold, nutrient-rich waters and lots of rocky shores and reefs to anchor to grow. While on Muir Beach, I discovered more than 5 different types of seaweeds, showing that it is a great environment for seaweed to thrive. It has tides that constantly move and keep seaweed growing, as well as cold temperatures and rocky reefs. Duxbury Reef is another great example of an optimal environment for seaweed. Its volcanic ash settled millions of years ago, forming tide pools that are home to many diverse seaweed species. Among those, I found 6, which were a mix of brown and red and green seaweeds, showing that they can free float, but also can anchor to rocks under the water. Due to the waves, Duxbury Reef's cliffs are constantly eroding, but seaweed helps because its bundles prevent the waves from having a huge impact, decreasing erosion. In an environment with a lot of fresh water, liminal water movement, and no rocky shores, seaweed has trouble growing and setting its anchors. This is why China Camp had less seaweed biodiversity and only contained 1 species of brown kelp, bladderwrack. Seaweed is so much more than something waves leave behind. It shapes ecosystems and affects how marine organisms interact with each other, and may even help climate change. Every small organism fits into the larger balance of our oceans. Studying seaweed showed me that even the simplest parts of nature have stories worth protecting.